You are welcome to my channel. Today we'll be solving a question from West African Senior School Certificate Exam, GCE, November-December 2016. And the question is on surface development. We have these two views which are elevations, and we have to draw the given views, then draw the complete plan and the development of the hopper, making XX. This is XX our seam. We'll make XX our seam. As you can see, the height is 50. This one at the bottom here is 30, and at the top here is 60. This is 60, and this one is centrally placed and it is 30. So let us start by drawing the given view first. Draw the given view first. With a vertical line somewhere here, like this. So at that point we can measure the height, which is 50. This is 50. So I can take in this one, 50. Then the bottom here is 30. This is 30. I make it thick up to this point. Then let me draw the horizontal line for the top. Yeah. At this point, I can measure my 60. This is 60 here. So then I join it to the bottom. Like this. Now, because we have to draw the complete plan, so let us leave 1 cm in between the two, the second diagram. 1 cm here. Then for this one too, let us extend this one a little bit downward and measure 1 cm to here. 1 cm. So for the second diagram, the top two is 60. So from here I can measure my 60. This is 60. So I can transfer this side downward, this point, the beginning, I can transfer it here. So from there, the bottom is 30 and it is centrally placed. Since this one is 60, we can put 15 at the beginning, put 30 and 15 at the end. So once we are able to get our 15 here, this is our 15, then you get 30. 1, 2, 3. So I make that one thick, then take it straight to this point. So this will give us our given view. That's the given view. Now, to get the complete plan, take this one like this. Just do it like you are solving a question in orthographic projection. Take this one here and this one too here. So now quickly write under this one according to the way it is written in the question. This is front, because all these things attract marks, and this is end. Now you need to draw 45-degree angle in order to get our view, our plan. So use a 45-degree set square to draw from this corner 45 degrees. So you can now transfer all the points downward to that line, all the corners, transfer them downward like this. You also need to transfer this one too, like this. So take them horizontally like this, and this one too, like this. Finally this one like this. In order to have a better picture of what you are doing, now you can convert this thing to isometric. Don't forget, this is our x, x. Now if we draw it like this, this, then it goes like this, comes like this, and this one goes here, and this one too comes here. Now this is our x. We can, not to get confused, let us use the one at the bottom as x prime. Now let us label this place. Since this is x, let us say this is b, this is c, and this corner is d. Now at the bottom we have x1 here, so we can say this is 1, this is 2, and this is 3. Now if we stand there and look at this corner, which is representing this one, we'll see x and d. Now at the bottom we'll see x prime and 3. So this is x prime and 3. Now at this other corner at the top, we'll see b and c. Then at the bottom we see 1 and 2. This is 1 and 2. Now similarly, that is, we look at it from this angle, which is what gave us this. Now if we look at it from this other side, we'll get here x, and when you are here, when you are viewing it from here, you are viewing it from this, because it is in first angle projection. You view from here, you draw here. When you are here, not this one, when you are here and you view this point will be by your left, and this point will be by your right. So we have x and b at the top here, which will be by the left. So we have x and b. Then for the bottom we have x prime and 1. Then this will be by the left. So we know we are viewing from here, so this will be by our left. We have d and c. Then at the bottom we have 3 and 2. Now let us now connect them. We have d and c here. It is meeting d here. You can see this d is coming here. It's meeting d here. Now similarly, we have c on this line. C here. You can see c is coming here. So our c is at this point. Now let us solve for the bottom, because that one is the one that may give us little challenge. We have 3 and 2 here. On this line, what do we have? We have our 2 here. You can see 2 coming here, meeting 2. Also we have 3 here, and our 3 is here, so it is here. Now for this other one, we have x prime and 1. We have our 1 here, and we have our x prime here. Now so that means this one will be a square like this. To give us a square like this, and this. Now similarly, if you look at this one, we have x and b here. X is coming here. Once you get to this place, you move this place. Our x is here, so we have this point here, and on this one we also have b. Where is our b? B is coming here. Immediately you get to this place, it crosses, it will meet b here. So this one will give us straight line like this. It will also be straight line like this, and this one will be connected to a straight line. That is like that. Then you will notice that x prime is connected to x prime is connected to x. It is along this line. Then here, what do we have here? We have 1 here. Our 1 is connected to b. Where is our b? You can see this is our b. B is coming here, it's meeting b here. So that means our b is connected to this one like this. Again, look at it. B is coming here. Once you get to this corner, it will change direction and it is meeting B here. Similarly, here, what do we have here? We have 2 here. You can see 2 coming here, going to this point. And it is also connected. Where is 2? 2 is connected to C. Where is our C? C is coming here like this. You can see it is meeting C here. So they are connected like this. That's how they are connected. So that's the connection. That is how they are all connected. Now, quickly write your plan under this. It's very, very important. Now, in order to develop this, we're going to use triangulation method. In triangulation method, we have to convert all the sides to triangles. So let us just connect, divide, put hidden line here, imaginary line there. Then you can connect this one too, like this. Then this one too, like this. So now let us now label. At the bottom here we have, don't forget we have our x1 here, x prime here, x prime at the bottom. Then here we have our 1, here we have 2, and here we have 3. And our x is here at the top, which is here. We have our x here. Then here we have our B, we have C, and we have D. So those are the labeling. So we can now begin to, let me put this drawing here. Just like this. This is x prime, 1, 2, 3. This is B, C, D. So that, let me erase this because we're going to use that space to draw our true length. Like that. So don't forget this one to go up here. Now, to draw it, remember our seam is x from here to here. That's our seam. That is from x to x. On plan, it is appearing like a horizontal line. You can see it is not the true length. Here to here is not true length. But from x to D is true length. That is from here to here is true length. So let us start by drawing a line at any angle of our choice. Let us move it as close as possible towards this side. Let's see. Now, if we take this as our 1, now, so we need to locate, it's as our x, not 1. As our x prime, that is the bottom, that is this point. Now we need to locate, determine the true length. That we want to, because this is our seam. We have been told to make x our seam. So we take it here, put it here like this, put it on that point. Now you go, this is the height of the elevation. Now you go to that corner. Make sure this line is perpendicular. You go to this corner and you mark this. When you mark this, now this line will be the true length of x prime. So you come to this place now like this, extend it to this one. This is x prime. You come here and you mark it here. So this is our x, this is x prime. Now it has to be thick, make it thick. Now x prime is connected to 1 and x is also connected to 1. So x prime to 1 is true length, because this square is the actual true length. This one to the bigger square is also true length, but all these slanting ones, both the hidden and the thick one, they are not true length. You need to determine their true length. So let us look for x1 here. You put it on this point, you come to this corner, mark the arc, that is x to 1. So you rule it. That is our x1. Like that. That's the true length. So you go to, that is x, which is this, not x prime. Yes. Don't let us start from that one first. We have gotten our x to, this is our, let us do xb first. Xb, this is x, let us look for b, because I said this is true length. X going to b is true length. So you put it on x and you look for b. You mark this arc, looking for b. Now, x prime is connected to 1. X prime to 1 is also true length. Let us put it here. X prime to 1 is true length. You stay here. You mark x prime to 1. And x is also connected to 1. You get this length. X to 1 first. X to 1 is this. You come here. You mark it. It is still at that same point. That is x to 1. X to 1. X to 1. We are looking for 1 here. So you come here and you mark your 1. So this point will be 1. Again, look at it. Let me recap. From x prime to 1, here to here, it is true length. You get this true length like this. You stay here. Come here. You mark the arc. That is x prime to 1. Similarly, x is connected to 1. You come here like this. This one is not true length. You come here, you get the true length, which is this. You open it here like this. That is x to 1. So you now come to this one, not x prime this time around, x to 1. You mark the arc there. When you mark it, this will be your 1. We can now join this like this. If you look at, if you have done it very well, you realize that this is 90 degrees. Now, x to b now. X to b is this arc that we have drawn. If you want to come, let us confirm again. X looking for b is this. You can see x looking for b is this arc. Now, x looking for b, and we have also obtained 1. 1 can also look for b. So you just put it on 1, going to b like this. Put it there. You come to this corner, get the true length. It is about the same point. It's shifting a little. So you come here now. Let us draw the line. They are very close. They are very close. Like that. That is x to 1. Again, put it here. Like this. Here. You can see it's on the same point. It's on the same point. X to 1. X, yeah, on the same point. So go to that point. X going to 1. X going to, no, sorry. 1 going to b. Is 1 going to b that we need to do. 1 going to b, let us confirm. It's 1 going to b. 1 going to b. Yeah, it's actually, I was actually right. 1 going to b is different. 1 going to b is different. So 1 going to b, put it here, extend it to that point. 1 going to b, 1 looking for b. You mark it like this. So you can now draw this with thick line. We have located our b and b. and B is connected to 1. We connect B to 1 like that. So this is our 1, this is our B. Now we have done this face. Now let us move to this face. B is connected to C. B, look for C. You take it on C, it is true length. B, look for C, is true length. Now C is connected to 1. So, and we have our 1 here. So we put it on 1, extend it to C like this. Go to this corner, mark the point Z. So take it back here. Now that is the true length. You come here, extend it to that point. That is C looking for 1 and 1 looking for C. You put it on 1, and we have been looking for C here. You place it here. So that will be our point C. So you can draw it like that. That's our point C. Now we have our 1. 1 goes to 2. You can see 1 comes to 2. How do you get 1 comes to 2? 1 going to 2 is true length. Stay there on 1, extend it to 2 like this. So you stay on 1 and look for 2. Look for 2. Now you can also see that C is also goes to 1. C also goes to 2 because we are looking for 2 here. So you get C looking for 2. It is not true length. You come here and determine its true length. That's the second line. You come here, extend it to the second point, which is this. That is C looking for 2. You put it on C and look for 2 like this. So this is our point 2. We can now take this one here like this and take it down to this place like that. That is our point 2. Now we can look for C going to D. C going to D, remember it is true length. C going to D, you put it on C and you look for D. Unfortunately, it will encroach into our drawing, so we have to manage it like that. C looking for D. Now also take note that we have obtained 2, and 2 is also connected to D. So let us check 2 looking for D. 2 looking for D. You put it here and come to this corner, the third one, that is this point. Extend it here. 2 looking for D. 2 looking for D will be here. So this is our point D. Take it here like that. Now D is also connected to 3. You can see D is connected to 3. So let us look for, but before then we can just get our 2 going to 3. That one is true length. 2 going to 3 is true length. 2 going to 3 is true length. Now D looking for 3. That one is not true length. We need to determine the true length. It is the first point, which is this. So put it here like this, because this point and this point, they are the same. So put it on D and locate here 3 like that, and take this one here like that. Now remaining the last step. This is our 3. We are here now, D to 3. We have done D to 3. Now our 3 is connected to 1. 3 goes back to x1 prime. 3 goes back to x1 prime, and 3 to x1 prime is true length. You can see that is at the bottom. Here to here is true length. 3 to x1 prime is true length. Stay here. 3 to x1 prime is true length. It will encroach a little into the drawing. Now also 3. Okay, our D can also be connected with hidden line like this. Our D, this is our D. it can be connected to hidden line to our x1 prime. So we put it on x1 prime and extend it to D. We are looking for x1 prime, and that one will not be true length. So we need to determine the true length of that, which is somewhere here. Put it and you rule it like that. So you come here like this, extend it to this point. That is D to x1 prime. D to x1 prime is here like this. So you can now put this one like that. Now this is our x1 prime. X1 prime. Now x1 prime is connected to D to x. X1 prime is connected to x, and D is also connected to S. Let us do our D connected to S. D connected to X, that is at the top. You can see it is true length. That one is at the top. D connected to it is at the top. It is true length. So D connected to X is somewhere here like that. Then our X prime connected to X. X prime, which is this first point. Let us bother ourselves. Just come here, you put it here like this. S connected to X prime. You see on this, connect it like this. So you rule with straight line like this, and this one comes back to this portion. This is our X. So at this point now, you can now change it to what is given in the question, which is X, not X prime. So you can remove the prime now. Now that you have done, I only put the prime to separate them so that we don't get confused. These are X. Here too, you remove the prime. This X. So that is the development of the Hooper of 2016 West African Senior School exam of 2016 November December. If you have enjoyed this video, do like the video, share the video, and subscribe to the channel if you have not done so. Thank you very much for watching. We'll meet in the next video, but don't forget to write development here. You can put it here, development, like that. So thank you.